Our topic for today is sequential function chart, SFC. This is one of the three graphical programming languages for PLCs. So remember, we had graphical languages, ladder diagram, LD, of function block diagram, and now we have the third one, SFC. So SFC is loosely based on the idea of flowchart, which has been used for decades for describing algorithms and computer programs. So as an example, let's say we have, I'll draw a little simple flowchart here. Let's have an oval labeled init. So that would be called a terminal. Another kind of symbol that represents that would be like a rectangle that has rounded sides, something like this. So that is going to be a place where we begin or end our program. In this case, it'll be where we begin it. We do some initialization. So this is a high-level description of what's going on in the flow of our program. Then we have arrows that are going to represent flow lines, how the program execution flows. We're going to have an arrow go into a little circle here where we can have two or more arrows joined together. And then we're going to go down into a diamond shape, and that's where we make a decision. So let me put this over here. So for us, this will be a terminal. Diamond shape will represent a decision. Okay, so where you could say we ask a question, and based on the answer, we do something. Okay, so this decision, let's label it start question mark. It's going to represent the answer to the question, is the start button pressed? And if the answer is no, well, then we're just going to go back and just continue to see if the start button is pressed. So here's the no result, that. If the answer is yes, then we're going to do something else. Into another little place where we can have multiple flow lines coming together. And we're going to go into some process here we'll call count. That's going to be in a rectangle. A rectangle represents a process. It's where we do something. And what are we going to do there? We're going to do some kind of counting. We're going to count the number of times a particular signal has a leading or rising transition. Okay, so we go into count, and we continue to do that until, and make another decision here. One's going to be labeled stop question mark. That means if we press the stop button, then we stop doing the count. If we have not pressed the stop button, we're going to go up and we're going to repeat the count. If we have pressed the stop button, well, let's write it this way. Let's go like so and go back and start the whole process over except for the initialization stage. Okay. So there would be a complete program represented by a flowchart. Again, we start at this terminal, this beginning terminal. We do some initialization things. Usually in a program, you have to set up some variable values or so on. And then we wait for the start button to be pressed. If it hasn't been pressed, we just continue to wait and just loop on that forever until the button is pressed. When it is pressed, then we go into the count process and we do some sort of counting, whatever that is. And we have to fill in the details here. This is just a high-level description. So we go into the counting process. And if we have not pressed, every time we do the count, if we haven't pressed the stop button, then we go and do the count process again. We just continue to loop into that. If we have pressed the stop button, then we go back and wait for us to once again press the start button. And we just sit there and loop forever until we press the start button, and we go back and do some counting again. Okay. So we never return to the initialization terminal up here unless we power down or shut off the program and then restart it. Other than that, we're just waiting for the start button to be pressed. Then we go into the count process, and then we continue that count process until the stop button is pressed. Okay, so that's a flow chart, an example of a flow chart. And again, sequential function chart is loosely based on this concept of a flow chart. There's some variations, but the basic idea that we have these different boxes that represent different processes with different what we'll call actions. We'll see here later. And then we have decisions that we make based on various logical conditions. And based on those decisions, we go to different processes in the program. So we're going to go over and use Logic Lab now and look at how we can basically implement this program that we've shown in this flowchart using sequential function chart. Now, what we're going to see is that sequential function chart itself can be called a high-level type of language. It isn't actually used to do things like actually set variable values or turn lights on and off and things like that. It's really used for a high-level description of what goes on. And then within these processes, or called steps in SFC, we can then actually have other programs in other languages, like ladder diagram or function block diagram, which actually get things done. Actually, the nuts and bolts then occur in those, or what we will call actions. So here we are in Logic Lab. So let's select File, New Project. Let's call this SFC1. And if we were doing a real project, we'd probably use a more descriptive name, but this is a made-up project to demonstrate sequential function chart programming. We want to make sure that the target is the virtual PLC there of the various targets. And we hit OK. So here is our workspace. This is what our virtual PLC looks like. Here are this tells us whether it's running or stopped. These are the digital inputs, which act like buttons in this case. These are digital outputs, act like LEDs. These are analog inputs and analog outputs. All right, we have a project tab and a resources tab. Let's go over to the resources tab, local I/O mapping. This is where you can actually assign variable names to these different inputs and outputs. We're going to have 3 digital inputs, 3 buttons, so to speak. One is the start button, and we have the count button. Right? Every time we press the count button, the count is going to increment. Now, in practice, that would probably be the output of some sensor that was sensing some, process. And then we're going to have a stop button. Okay, let's go down to digital output here. DOL0 is the first one. These are going to be LEDs that turn on that tell us, the first one is going to tell us if we're just waiting for the start button to be pressed. The next one is going to tell us if we are in the counting process. Finally, go all the way down here to the analog outputs, AOL0, and that is going to be the total count. So remember, in a PLC, an analog value is represented by an integer. If it's an actual analog voltage, that integer would be obtained from an analog to digital converter. And if it was an output and we wanted to actually create an analog value, we would feed that through an analog to digital, digital to analog converter. Analog to digital converter for the input and digital to analog converter for the output. But in our case, this is just an internal variable of type integer. All right, so those are our mapping of these different resources. We go back to the project tab and we're ready to now program and generate our program. Okay. Now, let's go up and right click on SFC1 project, add new program. So we want to remember, let's cancel that for a minute. Remember, we have 3 different tasks. The init task that runs once when the PLC starts up and then never again unless it's restarted. And then the fast and the slow tasks. So we want to do an initialization where we have to set variable values or turn things on and off just to get things initialized. So we're going to do that first. So right click, add new program. And now sequential function chart really isn't appropriate for setting variable values. It's a higher level description of program flow. So we're going to choose either ladder diagram or function block diagram. Let's do function block diagram. Let's call this FBD1 and assign it to the init task. Here's our workspace for that. Okay, and all I want to do here is just assign the total count value to be equal to 0, initialize it to 0. Let's right click, new object. We want an operator, and we want the move operator, which is the assignment operator. Here we go. So there's the move, that's the assignment operator symbol. And we want to assign 0 to the total value of the total count here. So let's go up here, and here's our symbols that represent the different function block diagram operations. If you're not seeing that, you can do View, Toolbars. Make sure you click FBD bar. All right, so to toggle that, let's select a constant, the K. Attach that there. We're going to have the value of 0 is going to be moved or assigned to. Now we use a variable. Okay, and the variable we're going to use is going to be the total running count. Okay, so that just assigns the value of 0 to total. Let's save everything. And let's go up to project and compile and see we get no warnings, no errors. Okay. Again, all that's going to do is, well, in fact, we can actually run the program. Let's go to debug simulation mode. That starts up our virtual PLC here. There it is. And we can stop it. Those. Stop it and start it. And all we've done is to set to a value of 0, this A out 0 analog output. All right, minimize that. Now let's go back to SFC1 project and now actually generate our sequential function chart project. So we right click on SFC1 project, add a new program. This is going to be sequential function chart. Just give it the name SFC1, and we're going to assign it to the fast task. All right, here's our workspace. So notice it gives you initially this box with the title of init. And this is our procedure here. And as it is, it's just describing the high-level operation of the program, not the actual details of setting variable values and the like. All right, this is called a step, actually, in SFC, rather than a procedure or process. So this is a step labeled init, and we already have init over here for our actual initialization. So let's go in here and double click on this. We could change the name. Let's call the name standby. This is where we're just standing by waiting for the start button to be pressed. Okay, so now we should have these different icons here for sequential function chart. If we don't, do view, toolbar, sequential function chart bar. And over here on the left, the three important ones are new step, new transition, new jump. Let's hit new transition. Click there. This is a transition. We can come up here and attach that, standby. So this would say, you're in standby. If true is true, which it always is, we would then transition out of standby. What we really want to do though, double click on that, is we want to transition when the start button is pressed. So we go to variable, start, and now this will transition when we press the start button. Otherwise, we'll just stay in standby. Okay, when we press the start button, we want to go in to the next process, the next step. So we want to come up here, new step. Now we can come over and connect that. More space if we need it. It's called step 0. Let's double click on that and change that name to count. This is where we're going to actually do the counting of whenever the count signal has a rising transition. And then we're going to stop the counting process when the stop button is pressed. So we go up here, new transition, connect, double click, variable, stop. Okay, so, and when we hit the stop button, we terminate the count, and then we want to go back to standby. We want to go back to waiting for the start button to be pressed. The way we do that here is with this, new jump. Okay, so jump, just called JMP for now. Connect that, double click, and here's where we can jump to. We can jump to either of these boxes, either of these steps, standby or count. We want to go to standby. This tells us we go back to standby. And that's our complete SFC program. We start out in standby. Of course, we've already done the initialization of the PLC. Start off in standby. When we press the start button, then we go into the count step. We do some things, and then when the stop button is pressed, we go back to standby. So unlike the flow chart, we don't actually draw a line up here. We use this little jump symbol. Kind of makes it, you don't get so many wires and lines that can end up crossing and getting a little confusing. Okay, that's our complete program. Now, what does this program actually do? Well, right now it doesn't do anything because these are just representations of some steps, but there's no actual things happening in those steps. We have to now actually use other programming languages to actually generate what we will call the actions of these different steps. Okay? So if we do F7 here, compiles, no warnings, no errors, and we could even go back and make sure we're in simulation mode. Oops. Simulation mode. Got our virtual PLC here. And go and then do F5 to upload our code into our PLC and run it. And well, nothing really happens here because we haven't actually created any so-called actions for these steps. So now we have to do that. To do that, we're going to actually have to generate some new programs. So let's right-click on SFC1 and select New Action. This opens up the SFC code type dialog. We can choose a programming language now for this particular action. Let's use function block diagram, excuse me, and give this the name standby underscore function block diagram 1. All right, now if we go and expand this SFC1 entry, we'll see that there's a actions submenu or folder really. And here's standby FBD1 in that. And double click on that. And then this gives us our programming environment for function block diagram for this particular action. So what I want to do first is I want to set turn on the waiting light, set that to true, and turn off the counting light. So to indicate to the user that we're in the waiting stage, and you got to press the start button to get going. Okay, so right click, new object operator, move. So we're going to make an assignment, and we're going to set up here a constant value, which is going to be true, assigned to the variable waiting. Here's waiting, double click. Okay, so that's going to set waiting to be true. That's going to turn on the LED corresponding to the waiting signal. Now let's add a new network after. New object, operator, move. And we're going to assign a value of false to the counting LED, counting, Boolean. Oops. All right. I'm going to double click. Click on that. Okay. All right. So let's save all of that. Save everything here. And now let's go and try to in our project compile everything. We get no errors. Make sure that we're in simulation mode. Then let's do online, download code, or press F5 to get the code into the virtual PLC or PLC. Let's start that up. And if we press the start button, well, nothing happens yet because we haven't assigned anything to count. And in fact, standby, we've come up with this standby program, but it should be telling us, one of these LEDs should be on, telling us that we're in the waiting mode. Okay, why didn't that work? Well, we have another step we have to take. Come over here to our standby block here and double click that. And now notice there's this code P entry and code N. P stands for pulse, meaning this is code that runs once when we first enter in this step, and then doesn't run again until we re-enter the step. And then the N, think of that as the normal code, that repeatedly runs as long as we're in the step. So let's go over here, code P, and select standby FBD1. Now that is assigned, so we see here, standby FBD1 is now assigned to the pulse code for that action. Okay, that action is assigned to the pulse code for SFC1. Okay, so now if we compile, no errors, and we've uploaded that code, and now we run this. Okay, now notice the waiting light turns on and the counting light is off. Good, that's what we wanted to have happen. Okay, so that is just done once there, and that's all that we're going to do in standby. Okay, so then if we press the start button, we should go to count. So in count, we want to change this. We want to make the waiting light turn off and the counting light turn on. So we're going to need some new actions. Go over to SFC1, new action. Let's use function block diagram, and let's call this count function block diagram 1. All right, and we can double click on that here, and now we can do our assignments. Move. We're going to move in this case, a value of false over to the waiting variable. We can just type in, right, and it'll auto-complete here. Waiting, space, new network, operator, move. And now this is going to be a value of true. Assigned to the counting. Oops. Counting variable, double click that. Okay, so this should toggle the values of those LEDs. Okay, so let's try. Now we go back to our SFC1. We double click on our count step and we can now come in with this code. So we'll do the pulse code. We just want to set these one time, the light values. Okay, so with that, let's see, let's save everything. Let's compile and let's upload and let's run this. Okay, so if I press start, notice what happens. We go down into count and now count changes the light. So this is the light that tells us we're in the counting step. Whereas if we're restart everything, we start out in the standby step. Press the start button, go to the counting step. Okay, so we got that so far. Now we want to actually implement the counting procedure. All right, so let's go up here, new action, and let's use a ladder diagram for this. And we'll call this count underscore LD2, say. All right. So up here, we've got now this count LD2, and that is going to be a ladder diagram program. All right, so this is where we want to actually keep track of the count. So let's make this contact, map that to the count button. And we're going to get rid of this coil. Don't need that. We want to input a new, let's see here, a new block. And we're going to use a count up timer, CTU here. Let's call this CTU1. There we go. There's our counting timer. Well, let's set the reset here. We'll set that to false. We don't want to reset it. We need a preloaded value of 0. Start at 0. And then the count will be assigned here. Select that. Assign that to the variable total. Okay, so that's just going to, every time we press the count button, every time there's a rising edge, we're going to increment total. Okay, so we go back to SFC1 now. Let's save that. SFC1. Now double click on the count step. And now for this, the normal code that we run repeatedly, select count ladder diagram 2. And if I did that right, we should be able to compile. No errors. Upload the code. Works, no errors. And now we can run this. Okay, so we're in the waiting step here, the standby step. If I press the start button, we go into the counting step. And press that. Now this is the count button. Now every time I press that, notice here the analog output 0 is going to increment. And we count 5 times. And now we press stop. That should take us back to standby. There we go. We go back to the standby. The waiting light is on. And now if I press the count, nothing happens because we're in standby. But if I press start, we go back into the counting operation. And now when I press the count button, we actually increment. And that happens as long as we are in the count stage. And if I hit stop, we go back up to the standby step. Okay, so that's our simple program that implements a counter, and it uses sequential function chart as the high-level description for the program flow. But notice we have to use other programming languages to actually fill in the details. And those then show up here as this pulse or normal actions associated with our sequential function chart program.